In this video, I'm going to talk about a little trick we can use when we do integration by parts. Okay, so I'm going to use this question as an example. Okay, so first we're going to do it using the traditional method. Okay, so the traditional method being, we have to identify what is dv and what is u. Okay, so let's introduce a 1 here. Okay. Okay, so if you go according to the LIATE rule, right, 1 should be our dv, right, because that will be the easiest to integrate. Okay, and then this would be our u, right, as usual. Okay, and the formula is, okay, let me just write it down somewhere here. Okay, so we're going to follow this formula here. So if you integrate this, right, is equals to u times v. U would be ln of x plus k, and v would be x, right? So normally we would write x, okay, and then this would be ln of x plus k. Okay, so minus integrate v du, right? So v is again x, and du would be 1 over x plus k. Okay, so k is a constant here, all right? Okay, so you see, if we do this, it's going to become a little bit troublesome, because you have x over x plus k. Okay, so, well, unfortunately, the numerator is not the derivative of the denominator. So we have to do a little bit of manipulation. Okay, so what I can do is I'm going to split it up. Okay, so this will be x plus k minus k. Okay, so we can actually split it up like that into two different fractions. Okay, so this is 1 minus k over x plus k. Okay, so let me integrate this. Okay, so let's simplify it a little bit more first. This will be integrate of 1 dx plus integrate, I'll take out the k, 1 over x plus k dx, right? Okay. So this is x ln of x plus k minus integrate of 1 with respect to x is just x. And you can see that, in this term, the numerator is, the numerator is the derivative of the denominator. Okay, so that's pretty helpful, right? So that will be plus k ln, right? So that will be a ln of x plus k. And then finally plus c, right? A constant. Okay, so if you want, you can simplify this a little bit more. Right? So this is x plus k. So I combine the terms with the ln x plus k minus x plus c. Okay. All right, so that's how we do it usually. Okay, but if you notice something, let me show you the little cheat. Okay. Okay. So this is how I'm going to do it instead. Okay. So the same question. Okay, so as usual, this is going to be our u, and the 1 would be our dv. Okay. Okay, so uv, right? So same thing. U is still ln of x plus k, but but for v, instead of x, I'm going to introduce x plus k. Okay, so this is my v. Right, so there's nothing wrong about that, right? Because if you think about it, right, when you integrate 1, it could be an x plus a constant, right? So I'm just going to pretend that the constant is plus k. Okay, and then u would still be ln of x plus k. Right, minus integrate v du, right? So this would be x plus k, which is our v, and du would be 1 over x plus k. Okay, so what do you notice here? This x plus k and the 1 over x plus k would just be simplified to a 1, right? So that actually saves a lot of steps. Okay, so this is x plus k ln of x plus k, and this is just x, right? Integrate of 1 with respect to x is just x plus c. So we arrive at the same answer, right? And you realize that, if you use this little trick here, it's much faster, right? Probably save half the time. Okay, so that's the little trick that I want to talk about. So if it is helpful, do remember to subscribe, hit like, and the bell button for notification. Thank you.